Welcome back, students. This is mathematics for Cbse class 10, and we have been studying chapter 2 algebra, in which we have studied about polynomials. We have introduced what is a polynomial, and we have introduced polynomials of degree 1, namely linear polynomial, polynomial of degree 2, namely the quadratic polynomial, and cubic polynomial and bi-quadratic polynomial. In the previous video, we have studied about what is a zero of a polynomial and how to find the zero of a polynomial in the case of a linear polynomial. Now, in this video lesson, what are we going to do? We are going to answer the 4 questions, namely, what is a quadratic polynomial? So we will recall what is a quadratic polynomial and what is its geometrical representation. How do we represent a quadratic polynomial geometrically? And what do we mean by zeros of a quadratic polynomial? And how to find them? So these are the 4 questions that we are going to answer in this video. Okay, let us now get into the quadratic polynomial. Okay, now let us write down the general form of a quadratic polynomial. So what is the general form of a quadratic polynomial? The general form of a quadratic polynomial is what is the general form. So general form of a quadratic polynomial is, let us write that as y is equal to p of x. So p of x is the polynomial. What is the polynomial? That is, this is a x square plus bx plus c, and we have to mention that without forgetting, we have to mention that the coefficient of x square, namely a, is not equal to 0, so that it becomes a quadratic polynomial. Otherwise, what will happen? If a is 0, so we won't have this term. In that case, it will turn out to be a linear polynomial. In that case, it would turn out to be a linear polynomial. So we have to ensure that the coefficient of the square term, namely coefficient of x square, need not be 0. So the coefficient of x square is not equal to 0. So this is what is the quadratic polynomial, general form of quadratic polynomial. Okay, now what are we going to do is, what will be the general form of the quadratic polynomial? What will be the, now we are going to answer the question, what will be general form of the quadratic polynomial? Quadratic polynomial. Okay, how do we represent this polynomial using graph sheet, using a graph sheet? Now let us look at the coefficient of x square, namely a. Look at the coefficient of x square. So if the value of a, as we have mentioned, that it should not be 0, it should not be 0. If a is greater than 0, so then a being a real number, now a comma b comma c, they are all real numbers. They are all real numbers. Of course, a may not be 0, a should not be 0. In fact, b and c may be 0. If there are 2 possibilities for a now, because a is not equal to 0. In that case, by law of trichotomy, that what do we mean by law of trichotomy? A real number can be either greater than 0, or it can be equal to 0, or it is less than 0. So when it is not equal to 0, it can be either positive or negative. So if a is greater than 0, what will be the diagrammatic representation? So this is the case 1. If a is greater than 0, what will be the diagrammatic representation? What will be the diagrammatic representation of the quadratic polynomial of this p of x? If p of x, that is equal to ax square plus bx plus c, and if a is less than 0, what will be the diagrammatic representation? So we are going to see these two cases. So what will be, again the same question comes, what will be the diagrammatic representation of this, and what will be the diagrammatic representation of the same quadratic polynomial? We are going to answer. Of course, for a general polynomial, see, whenever the polynomial is a quadratic polynomial, whenever a polynomial is a quadratic polynomial, y is equal to of the form ax square plus bx plus c with a not equal to 0, then its diagram is going to be, of this form. Its diagram is going to be of this form. It is going to be of this form. Diagram is going to be of this form. Let us draw a diagram. Let us draw the diagram. So it can be either the diagram is going to be like this. Either the diagram is going to be like this, okay, wait for a minute. Let us erase this because that's not the diagram that we are looking for. I'm not used to that. Okay, let us remove that. Now I'm not quite an expert in using this. Okay, now if where a is not equal to 0, now when a is positive, the diagrammatic representation is going to be something like this. So the graph is going to be something like this. So above the x-axis, can be above the x-axis, or it will be concave up, rather not above the x-axis, it is concave up, rather it is concave up. Suppose if a is less than 0, the diagrammatic representation of the figure is going to be like this. It is concave down. It is concave down. Now any curve of this type, of course we have not drawn the graph to the exact scale. Any curve of this form is what is called a parabola. So from this we see that every quadratic polynomial of this form, so every quadratic polynomial is represented by a parabola diagrammatically. Every quadratic polynomial is represented by a parabola, and we are going to verify that. Now we will verify that with the help of special cases. Now for example, what do we do here? Let us consider okay, let us take what? Graph sheet. Let us consider the graph sheet. Now in the general equation of the parabola, y is equal to p of x. In fact, this is a quadratic polynomial, right? Ax square, you consider the quadratic polynomial, not equation, quadratic polynomial of the form ax square plus bx plus c. This is the general quadratic polynomial. Now here what do we do is we take a to be 1, which is greater than 0, and you can take b and c to be 0. So in that case what will happen? The polynomial takes this form. The quadratic polynomial takes this form. If you want, you can write like this: y is equal to p of x and that is equal to x square. That takes this form. Now let us try to plot the points. Now what will happen? Let us plot the values of x here. So x value and the corresponding y value. When x is equal to 1, what will happen? Y is equal to p of 1, and that is equal to 1 square is 1. So when x is 1, y is also 1. When x is minus 1, of course we give only the integral value so that the plotting may be easier. So it is going to be minus 1 square again, which is 1. So when x is minus 1, what do we get is we get the value of y as 1. When x is equal to 2, y becomes y is equal to p of 2, which is minus 2 whole square, which is rather plus 2 whole square, which is 4. So when x is equal to 2, what do we get is we get 4. Similarly, when x is equal to minus 2, y is equal to p of minus 2, that is equal to minus 2 whole square. So all these things come from this equation, equation 1. So when x is equal to minus 2, y becomes 4. Now what do we do is let us try to plot the graph. So for example, let us try to plot here x-axis and y-axis. Let us take x-axis, y-axis here. Let us take x-axis, y-axis here. So this is y-axis, and let us take x-axis to be on this line, and negative x-axis is on this line. Now what do we do here is you plot the points. So you take, when x is equal to 1, y is 1. So let us first of all mark out here 1, this is 2, this is 3, this is 4. Likewise it is minus 1, and it is minus 2, it is minus 3. You mark the points. When x is equal to 1, y is also 1. So this is 1, and this is 2, and this is 3, and this is 4. So when x is equal to 1, y is equal to 1. So this is the point. This is 1, 1. This point gives you 1, 1. And when x is equal to minus 1, y is plus 1. So when x is equal to minus 1, y is, so this is the point. This is minus 1, 1. And when x is equal to 2, the corresponding value of y is 4. So this comes here. So this is 2, 4. So this is 2, 4. Likewise, when x is equal to minus 2 and the point comes here. So this is minus 2, 4. Now let us try to draw the graph by connecting the points. So what do we do is we join these points. We join the points here. Likewise, we join the points here. Now what will happen? Now let us try. When x is equal to 0, what happens? Y is equal to p of 0. That is equal to 0 square, which is nothing but 0. So that 0 also, this 0, 0 also lies on the graph. So you join these points and you join these points. So see, look here, look at the fact that a is equal to 1. We have taken a to be the value of we have taken value of this a to be greater than 1, and we are getting a parabola. This is a parabola which is concave up. This is a concave up parabola. See, this is concave up parabola. So when you take the coefficient of x square, namely when you take the coefficient of x square, namely a, to be 1 and it is greater than 0, what you will get is a concave up parabola. A concave up parabola. Concave up parabola. This is what you get. What will happen when if you take, what will happen now? What do we do is we just reverse the sign of a. We just reverse the sign of a and let us see what do we get. So in the same equation, what do we get is we simply replace the equation of the parabola. If we take the equation of the parabola p of x to be if ax square plus bx plus c, this is this general quadratic equation, and we are going to take a to be minus 1, which is less than 0, and you take b and c to be 0 as we did in the previous case. Of course you can take any other value, but still drawing will be much easier if we take b and c to be 0. Now what will happen? As we did in the earlier case, when x is equal to 0, y is 0. Y is equal to p of 0, that is equal to what will be the parabola in this case? In this case, if you take that, then y is equal to p of x, and that is going to be minus x square. So this is minus 0 square, which is going to be 0. So when x is equal to 0, y is 0. Likewise, when x is equal to 1, y is equal to p of 1. Y is equal to p of 1. P of 1 is minus 1 the whole square. So that is going to be minus 1. Likewise, when x is equal to minus 1, and again y is p of minus 1. This is minus of minus 1 whole square, and that is equal to minus 1 again. So from this equation 2 we get all the points. So we get all these points from this equation. Okay. Likewise, when x is equal to 2, y will be p of minus 2. Y will be p of plus 2 rather, plus 2. So when you put x is equal to 2 here, what you will get is minus 2 the whole square. So what am I going to do? Minus, this is plus 2 whole square. So what I will get is minus 4. In a similar manner, if I put x is equal to minus 2, again I am going to get y is equal to p of minus 2. So I am going to replace x by minus 2 here and here also. Okay. So if I replace that, what I will get is that is equal to minus of minus 2 whole square, and the value is going to be minus 4. Now let us collect the points. So collect the points. So value of x and value of y. When x is equal to 0, y is equal to 0. When x is equal to 1, y is minus 1. When x is equal to minus 1, y is minus 1. When x is equal to 2, y is minus 4. When x is equal to minus 2, even then y is minus 4. Now let us plot these points. Let us plot these points on a piece of graph sheet. Okay. Again what do we do is let us mark down x and y axis. Let us mark down x and y axis here, x axis here, and negative x axis there, y axis here, and negative y axis here. Okay. Now let us mark down the points. This point is the origin 0, 0, and this is 1, and this is 2, this is 3, and this is 4. Likewise, here it is going to be minus 1, this is minus 2, this is minus 3, and this is minus 4. Likewise, this is minus 1, and this is minus 2, and this is minus 3, and this is minus 4. Now you take x is equal to 0, y is equal to 0. So the point is this point. X is equal to 0, y is equal to 0. If you want, let us mark it in, and let us mark that point in 0 comma 0, and then when x is equal to 1, y is minus 1. So when x is equal to 1, y is minus 1, so this is the point under consideration. And when x is equal to minus 1, y is again minus 1, so this is the other point under consideration. Likewise, when x is equal to 2, y is minus 4. When x is equal to 2, y is minus 4, this is the point under consideration. And likewise, when x is equal to minus 2, y is again minus 4. Now when you join these points, what will happen? When you join these points, what you are getting is a parabola which is concave down. Of course, I have not drawn it to the scale. But when you draw it, when you draw to the scale, what you will get is exact parabola. So this is also a parabola. This is also a parabola. Corresponds to the quadratic equation. Parabola corresponds to the quadratic polynomial y is equal to p of x is equal to x square, and this parabola is concave down. Why it is p of x square is not x square, not x square, in fact it is minus x square, minus 1 times x square, concave down. Okay, concave down. Why it is concave down? Because the coefficient of x square is less than 0. Here concave down because what is the reason? The reason for that is a, the coefficient of x square is minus 1, which is less than 0. So as I said already, the general equation of the parabola, quadratic equation. So the general equation, the quadratic equation ax square bx plus c with a not equal to 0 represents a parabola. Represents a parabola of the type concave up when a is positive. The coefficient of x square, this coefficient of x square term, this term is positive, and represents a parabola of this type when a is less than 0. So this is the moral of the story that you have to remember. So it represents whenever the coefficient of x square, which is positive, a is x square which is a is positive, the parabola represented is concave up. When the coefficient of x square a, if it is negative, the parabola represented is concave down. But in either case, this curve always represents, this quadratic equation always represents a parabola. So this is the moral of the story that we have to remember. So this is the diagrammatic representation. So this always stands for a parabola. The general quadratic equation in x always stands for a parabola. Okay, this is the answer for the second question. Now we will answer the third question, namely what are the zeros of a quadratic polynomial and how to find them. What are the zeros of a quadratic polynomial and how to find them. Now for example, let us consider an example. In fact, we have to consider 3 examples. Okay, now let us consider example 1, which is a simple example. What is that? Let us consider a polynomial p of x is equal to x square minus 5x plus 6. Now what are we going to do is we are going to break this quadratic polynomial into 2 linear polynomials. We are going to break this. The breaking is otherwise known as factorizing. We are going to factorize this into two linear polynomials. This into two linear polynomials. Two linear polynomials. And remember that not every quadratic polynomial can be factorizable. This is an important point. Now we can factorize this, and you know what is the coefficient of x square here? What is the coefficient of x square here? The coefficient of x square is 1. Now what do we do is, you multiply the coefficient of x square and the constant term. So you write here, multiply the coefficient of x square and the constant term, which is 6. Now what are the possible products of 6? 1 times 6 and 3 times 2, that is 6. But what do we have in the middle? We have minus 5 in the middle. So I am looking for two numbers which are negative. When you add them, you will get minus 5. When you multiply them, you will get plus 6. Obviously the option is 3 and 2, but they are positive, but I have to make them negative. So I will make these two as negative. When you multiply this, when you put product for this, you will get, when you add them, what you will get is minus 5. So this is what we call it as splitting the middle term. This is what we call it as splitting the middle term. Why it is so? Because x square, I am going to split this into 2. This is 2x minus 3x plus 6. So what I have done is, I have splitted this term. I have splitted this term. I have split this term into 2. So I have split this into 2 terms. Can you look? Minus 5x is broken into two factors, namely minus 2x minus 3x. Minus 2x and then this 6. Now from the first two I will take, from the first two terms, what I will do is, I will take x common. So I will be left with x minus 2. And whatever I have here, I copy down here x minus 2. I'll ask the question, what should be multiplied to minus 2 to get 6? So obviously answer is minus 3. And you can check now whether you are getting these two terms. Minus 3 times, now minus 3 times x is minus 3x, minus times minus is plus, 3 times 2 is 6. So we are getting the answer. So what do we do now is, this is what we call it as factorization. Now you take x minus 2, which is common in both the terms. So you will be left with what? You will be left with what? X minus 3. What we have done here is, we have factorized. What we have done here is, we have factorized the polynomial p of x, quadratic polynomial p of x, into two linear polynomials. So one polynomial is x minus 2, the other polynomial is x minus 3, and we know the zero of this linear polynomial. So 0 of x minus 2. 0 of x minus 2. What is the 0 of x minus 2? When this becomes 0, and this becomes 0, this is equal to 0, x minus 2, 0 are. So for the polynomial to be 0, one thing is x minus 2 should be 0 or x minus 3 should be 0. The x minus 2 is 0 only when x is equal to 2, and x minus 3 is 0 only when x is equal to 3. Or you can do this way also. And you take the polynomial x minus 1 into x minus 2 is equal to 0. This is the linear polynomial. And you know the formula for the linear polynomial. You take the polynomial to be, say, q of x. What is the 0 of the q of x? We know the formula, 0 of q of x. You can do this way also. Minus constant term minus 2 by coefficient of x is 1, which is nothing but 2. In a similar manner, you can do here also. If you take h of x, to be x minus 3, and then 0 of h of x, we know the formula. 0 of h of x is nothing but minus constant term minus 3, and that is divided by coefficient of x, which is 1. So you have 1 here. which is nothing but 3. Now what we have done here is the method that we have used is divide and conquer. So if it is possible for you to factorize the polynomial into two linear polynomials, so you divide that. So divide a quadratic polynomial into two linear polynomials, and we know the formula to find what? The zero of a linear polynomial. Using that we can find the zeros of the quadratic polynomial. Therefore, what is the conclusion? Therefore, x is equal to 2 and x is equal to 3. They are the two zeros of the two zeros of the quadratic polynomial p of x. Quadratic polynomial p of x. Now we are going to see what is its meaning. Okay. See, if you take the polynomial, if you take the polynomial y is equal to p of x is equal to x square minus 5x plus 6, and when you substitute when x is equal to 2, y is equal to p of 2 is going to be 0, and when x is equal to 3, then y is equal to p of 3, and that is going to be 0. What does it mean 0? So what is the meaning of a 0 of the polynomial? That's what we are going to answer. So if you draw the parabola for this, so if you draw the parabola for this, so you will have a parabola, because the coefficient of x square is greater than 1. Coefficient of x square is greater than 1, and so since it is greater than 1, the corresponding parabola is concave up. And let us mark the points. This is 1, and this is 2, and this is 3. And it says when x is equal to we have given 2. What will happen? So the parabola passes through these 2 points. So let us mark out. So these are the points. So 2, 0 and 3, 0. So these are the points. 2, 0 when x is equal to 2. So it becomes 0 here, and it becomes 0 here. So the parabola somewhere here, the parabola is something like this. So the parabola passes through this way. So this is how the parabola is. So the parabola like this, something like this. Parabola is something like this. So when you draw the parabola, that means this is what we mean by that. So parabola is something like this. That means what? This means that the parabola cuts the x-axis or meets the x-axis at the point 2, 0 and 3, 0. So these are the points where the parabola, which parabola? This is the parabola. This parabola meets the x-axis, x square minus 5x plus 6. This meets the x-axis. So this is the geometrical meaning of 0 of the polynomial. How do we found the 0 of the polynomial? We found the 0 of the polynomial by splitting the middle term. Now we answer a question. Suppose if the parabola is like this, y is equal to p of x is equal to x square plus 1. So this is also a parabola, but unfortunately for this parabola is not going to be 0. The value of the polynomial, note that the value of the polynomial, note that p of x is, see, remember, never 0. P of x is never 0. P of x is never 0 for any for any real value x, for any real value x, p of x is never 0 for any real value x. Real value x. What does it mean? See, when x is equal to 0, see, we can check when x is equal to 0, p of x, rather when x is equal to 0, what will happen? When x is equal to 0, y is equal to p of 0. You put x is equal to 0 here. You put x is equal to 0 here. So what do we get? P of 0 is 0 square plus 1, which is 1. So you collect the point 0, 1. When x is equal to minus 1, when x is equal to minus 1, y is equal to p of minus 1. You put minus 1 here. You put minus 1 here. So what do we get? We get this is minus 1 square plus 1, and that is equal to 2. So this is 0, 2. And when x is equal to plus 1, if you put x is equal to plus 1, y is equal to p of 1. This is 1 square plus 1, which is again 2. So this is when x is equal to 1, y is 2. And I made a mistake here. I am replacing when x is equal to 1 minus 1, even then it is plus 1. So when you try to draw graph for these points, for this point, this is x and y. When you try to draw graphs for these points, so by keeping this as x-axis, this as x-axis, and this as y-axis, x-axis and y-axis, and this as x-axis, you will have a parabola. Where you will have a parabola, the parabola is going to be, the least value is parabola. And if you mark the points as this as this is 1. Wait, let us mark the points as this is 1, this is 2, this is 3, and if you mark this as 1 and this as 2, and so on. So what do we get is, when x is equal to 0, parabola takes the value 1 here. When x is equal to 1, parabola takes the value 2. When x is minus 1, the parabola is this. So the parabola passes through these points. Not here, here. So this is not the point. So this is where it passes through. Okay, this is where it passes through. So the parabola never touches x-axis. So this is x-axis. So this is the parabola. This is the parabola. Y is equal to px, that is equal to x square plus 1. This never cuts x-axis. This never cuts x-axis. This parabola never cuts x-axis. That means what? This parabola never cuts x-axis. Never cuts x-axis. So here it's never cuts x-axis. Here we observe an important point. What is that? What is that? So this parabola, this quadratic equation, namely y is equal to x square plus 1. Okay, let us say if we want, let us write like this. So y is equal to px. This is a quadratic equation. This is a quadratic equation. This is an example of a quadratic equation. It's an example of a quadratic equation which has no zeros at all. Which has no zeros at all. No zeros at all. So there can be quadratic equation without zeros. There can be quadratic equations no zeros at all. In fact, let me add one more point. No zeros at all in the real number system. Let us add the system in the real number system. because whatever may be your real number, for x whatever may be, you can give x can be any real number. So for any real number this can never be 0, this expression can never be 0. So it's an indication that this is a great example or good example to understand that there are quadratic polynomials, example of a polynomial without 0, example of a polynomial without 0. So without 0, of course you can give several examples like this without 0. And in the previous example we have seen that at a parabola with two zeros, a parabola with two zeros, so which is the degree. So degree of a quadratic equation. And let us see one more example and we stop. Okay, let us see one more example and we stop. Okay, let us consider the parabola again. Let us consider the parabola y is equal to p of x, and that is equal to x square minus 2x plus 1 if x square minus 2x plus 1. Now let us, this is also a parabola, which is a parabola, and here the coefficient is a is equal to 1, which is greater than 1. Therefore the parabola is because here it is 1, so it is a is great, therefore it is concave of parabola, that is of this form it's going to be. And when you try to find the zeros, now what do we do is, when x is equal to 1, if anybody is if some of you might have noticed that this is nothing but x minus 1 whole square, right? X minus 1 whole square, because a square minus 2ab plus b square, right? So when x is equal to 1, what will happen? Y is equal to p of 1 is going to be 1 minus 1 whole square is going to be 0. And when you try to draw the graph for this, parabola, this is also a parabola. When you try to draw the graph for this, so what you will get is you will get a parabola of this form. What you will get is, when x is equal to 1, it becomes 0. So let us take x to be 1 here. And you might have got the parabola like this. Parabola touching the x-axis. This is the parabola corresponding to the quadratic equation x square minus 2x plus 1 or x minus 1 whole square. So this is the parabola. Y is equal to p of x rather. Okay, y is equal to p of x. If you want, you can write y is equal to p of x. So this is the parabola. So in this case we see that this parabola touches this parabola touches, see, this parabola touches cuts the x-axis, or parabola touches the x-axis exactly once, touches the x-axis at only one point. In this case we say that x-axis, in this case we say that x-axis is a tangent to the parabola. We say that x-axis is a tangent to the parabola. So we have seen three different cases so far. What are they? Y is equal to p of x. If this is the equation of parabola, general equation of parabola or general quadratic equation, there are three possibilities. So 1 represents a parabola. Equation 1 represents, so this is the story that we have learned so far, represents a parabola and it may cut the x-axis at most at 2 points. So in the case of the at most at 2 points, in the case of this equation x square minus 5x plus 6, so in this case at most at 2 points, or it never cuts x-axis, never cuts x-axis, that means no zeros. So example is x square plus 1. Here two zeros of the polynomial, quadratic polynomial, 2 zeros case, or it may touch x-axis. It may touch x-axis once. It may touch x-axis 1 0. So there are 3 possibilities. These are the only 3 possibilities. Example of that is x square minus 2x plus 1. So these are the only 3 possibilities. So given a parabola, given a quadratic equation of this form, it can cut the x-axis at the most 2 points. It can cut the x-axis at that most 2 points. In that case, the given equation has 2 zeros, example of which is shown in the first example, and it never cuts x-axis, or the given quadratic polynomial has no zeros at all. The example of a polynomial of this, and it may touch x-axis. The parabola may touch x-axis, and in that case it has only 1 0. The corresponding quadratic polynomial has only 1 0, and this is so. We have answered all the 4 questions. I hope you understood the points mentioned here. Thank you for watching.